Thank you, everybody, for allowing me the opportunity to present to you all. I'm the architectural rep here in Texas. However, I do cover quite a bit of territory, which includes the states of Texas, Oklahoma, Arkansas, Louisiana, Colorado, and Wyoming. However, we do have architectural representation across the country. And if you need any assistance with that and who to get in contact with, please feel free to reach out to either Isaac and I, and we'll get you accommodated. So I cannot hand a card through the screen, as you can imagine. So please feel free to take down my information if you do have any questions, or if you are in my territory and you would like to have this just as personal reference, please feel free to reach out. And I am on LinkedIn. If anybody would like to follow me, please feel free to follow me via LinkedIn, and I will happily accept. Just to give some background on WR Meadows. So we are a manufacturing company of Division 3 and 7 building products. We were actually founded in 1926 in Elgin, Illinois. However, that office is actually relocated to Hampshire, Illinois due to building code regulations. We are private and single family owned. However, we are a very large company within North America. We do have 12 facilities, 3 of those of which are going to be in Canada. And we do have a sister company called Blue Ridge Fiberboard. They're going to be our company manufacturing sound dampening products such as insulation board and other acoustical materials. This is a map just to show where our branches are located. So the yellow dots will represent where we actually manufacture a majority of our materials. And then the gray dots will actually represent some stocking warehouses, just for the sake of making sure that we have easy accessibility for any of our contractor partners to get materials for their job sites. For our family of products, we were originally just an asphalt expansion joint manufacturer when we were first founded. However, we continued to grow and expand beyond our concrete needs. This includes concrete restoration, which will be your back products, such as repair mortars, grouts, epoxy grouts, as well as epoxy injections. We also have construction liquids. This is a big part of our business. This is going to range from curing compounds, both resin-based, wax-based, type 1, type 2, class A, and class B. And we also do have acrylic membrane sealers. We have penetrating sealers. Both of these are going to be in either solvent-based or water-based. And we do also have penetrating sodium silicate and lithium silicate densifiers and hardeners for your polished concrete or warehouse needs. For joint sealants, we have polyurethane. That plant is actually here in Fort Worth, Texas with me, and that is going to be for your typical paving. However, we do also have rubber crack fillers, which will range from rubber polymeric that are in low modulus as well as high modulus. So if you ever drive on the road and you see this black squiggly line, that is the product I'm speaking of. For decorative, this is going to range from acrylic sealers to penetrating sealers. We'll typically see these products for enhancing the overall look of colored concrete, stamped concrete, as well as decorative pavers. But for today, we're focused on building envelope, and we're not going to be going over our products in general during the presentation as it's non-proprietary. However, if you are curious, we do manufacture underslab vapor barriers and vapor retarders. We also make below-grade waterproofing, both sheet and fluid, etc. And we also have above-grade air and moisture barriers and vapor barriers, as well as introducing our products for green roof, vegetated roof, and paver applications. Blue Ridge Fiberboard, again, they are going to be our soundproofing and insulation board. I personally do not work directly with them. However, if you have any questions on this, I will happily get you in contact with the appropriate representation. As I mentioned, this is an AIA approved presentation. This is going to be a non-proprietary presentation, and everybody in attendance will receive 1 learning credit for their attendance. So our presentation today is basics of moisture movement through the building enclosure. So it is going to be a fairly beginner presentation, but we will cover quite a bit of content. And really what we're going to go over are moisture movement phenomenons that actually occur pretty much on a daily basis. But we're also going to talk about some of the factors and issues that can come from this. And so with that, we want to protect our buildings. And we also will identify those products that are in our industry that help us prevent moisture movement. But we're also going to go over some basic design details that are very important for the sake of making sure we have continuity. And we'll also go over some practices and solutions that actually can help us save time, but also help us potentially get a much better installation from the contractor because not every product is for every situation. But when we think about the building enclosure, it's not so simple. We don't just simply put something on the wall and we're protected, right? When you think about it, moisture can occur in all six sides of our building. And so we really want to make sure we have that continuity. And majority of the time, these systems will have to connect and work together. So we're not just going to look at one side. We are going to accommodate both the underslab, the below grade waterproofing if necessary, and the above grade air and moisture barriers, as well as the roof. But how does moisture movement actually occur? Well, it starts off with the hydrologic cycle. So this is simply a process where our large bodies of water will heat up, they evaporate, they'll condense into clouds, and then we get precipitation in the form of rain, sleet, or snow. Well, as the moisture falls back down to Earth, it naturally wants to make its way back to those bodies of water so the cycle can repeat. However, when we build our structures, we are indeed disrupting this cycle. You will actually get moisture movement from the area of high pressure to area of low pressure. You can have gravity, which can cause hydrostatic pressure below grade. We'll cover that very briefly here later. Capillarity is another phenomenon. This happens especially in concrete, simply because concrete's very porous, and concrete will have a lot of capillaries that are not in a straight line. So ultimately, when moisture comes into contact with that wall, it doesn't mean it's just going to enter at that point of contact. It can make its way in different directions within our building, making it hard to pinpoint where the leak is actually occurring. And with something being porous, which is not just below grade, but a lot of our building components above grade, we can get natural diffusion both in a gaseous state and a liquid state, which is simply water being able to permeate through a building material. When you punch a hole through it, you have air transportation. And likely that's going to cause more issue than just simply diffusion. And so we do have to make sure we have that continuity. And lastly, we have dew point. Now, dew point obviously is going to be the temperature at which moisture can no longer be held in a gaseous state or the form of vapor, and it's going to actually form a liquid on the side of a solid surface. And how this is achieved is when you have basically two conflicting temperatures come into contact with each other because moisture is in our air. And whether you're in a dry climate or down in the south near the coast, you will have some moisture content in the air. And naturally, when you get that vapor content touching a very cold surface, we start getting liquid condensing on that surface. So if you have steel studs within your wall, that is going to be an issue in terms of condensation could form within that building. And this is why we have the incorporation of things like insulation, as well as having something such as a WUFI assessment to dictate where the dew point can actually potentially meet within our building. So when you think about moisture movement by air, as I mentioned earlier, vapor diffusion is a way for vapor transition into our buildings. However, when you take a 4x8 sheathing board, this case gypsum, and we put it in a very humid climate, maybe such as Florida, we're going to have an interior conditioned space around 70 degrees, but 40% relative humidity. And with vapor diffusion, that area of high pressure, which is going to be outside, is going to make its way to the area of low pressure, which is within our conditioned space. So through that building material, we get about a third quart of water. Doesn't sound like it's too much water. However, we do want to multiply this piece of sheathing times however many pieces are actually being used to construct our building. So it can become quite a bit of water without any protection on that wall. But you punch a 1 inch by 1 inch hole, as you can see here, it becomes a much more critical situation. We'll get 30 quarts of water, and again, this is just for one piece of sheathing board. So as you can imagine, any hole or any opening is going to be an easy pathway and the least path of resistance for moisture to make its way in our building. And a lot of times, it will just carry moisture-laden air from the area outside to the area inside. For our colder climates, when we heat our buildings, that's going to escape from the inside to the outside, which can also move the dew point in areas we don't want it. So when you speak about dew point or just overall air leakage, We have to understand that it's not a matter of just having a hole in the wall. So many different building components are going to make connections to make up our building envelope. And when you have all these different building envelope components connecting, that's a pathway for air leakage to occur. So when you look at the graphic here on the right, this demonstrates that it's not a matter of a hole. You have all these different connections, and it's not really a straight line as far as how the air infiltration can occur. Whenever you are in a warm climate, again, the hot air from the outside naturally is going to want to move to the inside, which potentially may move the dew point to an area we don't want it. A rule of thumb, high pressure is always going to want to move to low pressure to reach a state of equilibrium. The same thing is going to be with temperature. Hot is always going to want to move to cold. So we can't control physics, we can only deal with it. So what happens when moisture does become an issue within our buildings? Well, aside from the fact that we don't want any liquid water underneath our feet in our building, we also want to make sure that we protect it from damage. So when you think about interior furnishings, such as maybe your wallpaper, you think about bad insulation as well within the wall assembly, they can start becoming damaged. And then if you have things like wood or steel, overall, you can actually damage the framing of the building. So steel studs will tend to rust or have a carbonation effect. And then you also have to think about the fact that wood contains mold spores. And so we will get mold over time. And in any restoration project, this is one of the leading findings that we find due to failure of moisture control. But for those colder climates, when you look at the graphic on the bottom right, you can see that the heat making its way to the outside. This is largely in part because the brick is directly against the wall. Most of the time, we like to see some cavity space, but when you miss some areas of detailing, you can start seeing this moisture condense on the face of the brick and causing this phenomenon, which over time will actually deteriorate that brick. And lastly, we want to make sure people are comfortable, right? Well, if your HVAC systems are constantly running, you may make helping people stay comfortable, but you're also decreasing the life cycle of those HVAC systems because they're continuously having to run to achieve the conditioned space that we set, temperature that we set it at. Now, from water control, when it comes to an above grade setting, there are several ways that we help prevent moisture intrusion. First one is deflection. Now, this can be achieved by simply incorporating metal drip edges at the windows. We'll have some eaves that can collect water and also help shed water away from the building. And then we may decide that we want to incorporate a roof, a sloped grade. Ultimately, how do we shed water away from the building when it comes in contact? But it's also important to note that water will at some point get behind our facade, or in some areas that it's going to be behind the finish. So we naturally want to be able to drain the water away from the building. So can be achieved by flashings within our rough openings. This is just to make sure that when water touches those openings, it also has the ability to channel back to the wall. And then we also may have openings such as joints, maybe a rain screen system or an open cladding system. This is to make sure that water does not get trapped and we can have it escape the wall. And then you also have to incorporate your base of wall flashings, because if we make ourselves down the wall, we want it to channel back to the outside of the wall. With this, we also use capillary breaks, which I'm always going to call this basically the membrane that separates the external conditions from the internal conditions. So this will be your air barriers or your air and moisture barriers, depending on what we need for the protection. And then we oftentimes will have to transition to the waterproofing at the foundations. Sometimes this may not be the case. We may just have a base of wall flashing because it's a slab on grade. However, we still want to naturally channel the water away from the building in that area. For vapor control, there are several approaches that we use. Now, I do want to make note that not every product that we use is going to have a vapor control layer. So when you think about things such as building wraps, those will constitute as our air barriers, but they will not have the vapor control layer. We may have the vapor control layer separate, but it is included within the wall, such as maybe vapor control on the inside of the wall, and then your air barrier simply on the outside. This is a beginner presentation, so we won't cover too much on where that's located. But ways that we control vapor are flow through assembly. So this just simply means that the vapor can move freely within the building so we aren't trapping it in some of those interstitial spaces. So in other words, you have a fairly breathable building. Sometimes we will control vapor with a vapor control layer. With an air barrier that has vapor control, oftentimes that means that we don't have any potential for moisture to enter the building on the outside, but we still want to make sure that we have moisture's ability to dry inward in that case. And we also want to make sure that the surface temperatures where condensation can occur, that they don't occur, and we use insulation. At times, we can have insulation just in a form of bad insulation within the wall. We may have continuous rigid insulation outward. This is required by code in some territories, such as the North. Or we may even have something called a hybrid wall, such as the bottom right photo, which is going to have insulation, rigid insulation, and bad insulation. So it's really going to be dependent on how we want to control vapor, but this is where we dedicate that information to our engineers. The ultimate goal, though, is just to ensure that we design a building with complete drying capability. We want to make sure we do not have two vapor barriers within our wall. But in theory, air leakage should be pretty easy to deal with, right? You put a membrane on the wall, you make sure that everything is continuous, we eliminate any gaps or cracks. However, it is easier said than done. And at times, when you uncover an existing building's wall, you make it what we see on the right. Now, if I had to guess, this wall is probably not up to code, but there is no continuity at all within this. And this is a very critical restoration project on our hands here. So what are the types of air barrier materials? Now we're getting really in the meat of the presentation where we can discuss what systems are available in our industry. So what we're going to review are sheet membranes, mechanically fastened sheets, spray foam, as well as fluid applied membranes. So for sheet, we have self-adhere sheets. Now self-adhere sheets can come in both permeable or impermeable when it comes to vapor control. Some of our benefits related to sheets is the fact that it is going to be more contractor friendly in terms of mill thickness. When you think about fluid applied membranes, we are at the mercy of the contractor to install it at the correct thickness. But with sheet membranes, it's simply installed correctly without the thickness component having to be a concern. We ultimately just do need to ensure that it's detailed appropriately and that we have the correct accessories to make the detailing and transitions. So you also want to take into account that if you have a building that is directly next to a parking lot or another building, well, fluid applied membranes may have something called overspray because they use chicken sprayers to spray, or gray coat sprayers. So we don't want overspray potentially being an issue and landing on somebody's car or window. So that's where another area where sheet membranes may be preferred. But then we also have fluid applied membranes. Now, fluid applied membranes benefit is simply the fact that you cover a lot of square footage in a short amount of time, which is obviously great for construction schedules. But also, it's monolithic and you have a lot less detailing that has to be achieved in terms of overlaps of the membrane. When you look at the photo on the top middle, you'll see that that's a lot of square footage, but it's ultimately one piece, right? Sheets overlap, we have to terminate it with the appropriate mastics. Whereas this is simply going to be an easily prepped wall, just needs to be clean and we can spray or roll. One thing to note too is that this does not require a primer compared to our self-adhered sheet membranes that are impermeable because rubberized asphalt will need a primer. But with fluid applied, it's simply spray on the wall, make sure the wall is detailed appropriately prior to the spray. You also have a variety of chemistries that are available, such as water-based, solvent base, asphaltic base, STBE, which is solid terminated polyether, and then you even have polyurethane. So there are a variety of options that are available. And some of these membranes may have better UV resistance capabilities. Some of our sheets may only have 30-day, but with a lot of the fluids, we can get upwards to 5 months, 6 months. Some can be indefinite. So there are a lot of options. And as you can see from the photo on the bottom left, it doesn't require as much labor compared to a sheet. And so we are saving on overall labor costs. Foamed in place insulation. When it comes to wood studded structures, this is kind of considered the holy grail simply because it can handle all four control layers: your air, your vapor, your water, and your thermal. Reason why we don't see it as much in seal studs is simply because it cannot accommodate for the thermal bridging that can occur. The only way that we could potentially do that is if we encapsulate these studs completely. But depending on the budget of your owner and if it's a wood studded structure, these are great options to use. Other things to consider as general air barriers, we do have mechanically fastened board stock insulation. And so when you think about insulation board as your air barrier, do understand that the joints do have to be treated and sealed. Some manufacturers of this may recommend a liquid flashing type or a tape. Look at the top right photo, you'll see that all the joints are accommodated. One thing I do want to make note of is that when we do use insulation as a dedicated air barrier, understand that if there is damage to the insulation, we inadvertently have affected all four control layers. So this is typically why we will see a dedicated air barrier membrane behind insulation. Sometimes we'll even see it on top. I prefer it behind the insulation just because I want that capillary break closest to the wall. Then we have mechanically fastened sheet. So this is a really good economical choice, especially when you think about plywood sheathing in wood studded structures, simply because it's installed via staples. It's a pretty easy installation. It's going to be one of your lower cost options. And ultimately, for residential projects or some of the multifamily, this is one of the go-to products that we have seen. One of the things that we do want to make note of, though, is the fact that it is not bonded to your wall. So if water does get behind it, it will run down the wall, which makes pinpointing a leak a little bit harder to find. Also, if there is a wind pickup, this material can be ripped up fairly easily because staples are the only thing that are supporting this. So it's also important to note that when you do have many staples and fasteners going through it, that is a pathway for air leakage to occur and it needs to be detailed appropriately. So it does require quite a bit of babysitting, but if it's achieved correctly, it can be a good system for your walls. A quiz, which of these is not an air barrier? I'll give you about 5 seconds to look at it and then I'll answer for you. The gum wall and peanut butter are pretty suspicious, right? But it's actually a trick question. All of these are going to qualify as an air barrier. The reason being is because when it comes to industry standard, the IECC and even the IBC, which is the code for short, basically they don't take a hard stance on what qualifies as an air barrier. It's simply going to be something that stops the flow of air, and typically the material defining standard is going to be E2178 for air permeance. Well, quite frankly, most materials in our industry or in the world can qualify as an air barrier, but the thing that the code isn't going to take into account is what are its water resistance capabilities? What's its UV exposure like? What are the costs for it? And do we have all the accessories to maintain continuity and what is compatible? And so these are just a variety of things that we do want to consider before we write our specifications. Here's another quiz. I'll give you 5 seconds to look at it and I'll answer. What type of air barrier is best for this type of wall? It's a CMU block wall with brick ties pre-installed. Well, another trick question. Well, quite frankly, you don't want to use a sheet at all because, quite frankly, how many of you would love to poke a hole for every brick tie on the wall? Most contractors will hate it, but more importantly, it's going to be an ineffective application. You can use sheet on this, but I rather only use the sheet on this wall if the brick ties are going to be installed afterwards. Typically, fluid applied will be preferred because CMU block is very porous, which means that it's going to soak in some of the liquid, but also it's going to be a rougher profile for some of the sheet membranes. Also, you can spray directly over the brick ties as opposed to having to poke a hole or have the sheet installed first. So we just covered above grade, and now we're going to move to below grade. So this is going to cover everything that's going to happen in the earth or under our building, and this is going to accommodate damp proofing, waterproofing, vapor proofing, as well as drainage. So when you think about below grade, vapor is a consideration, but ultimately we're trying to make sure liquid water within the soil or the grade is not going to enter our building. But how does it enter our building? Well, if you build any building near a large body of water, water can move laterally with ease within the soil. And so a high water table can be a dangerous area for a building, but that's where you're going to have your more robust systems for protection. When you think about irrigation, that's continuous new water. And most landscaping that surrounds our structures are going to have some type of irrigation system. And that's where it ties into the site drainage discussion. We need to ensure that moisture cannot accumulate continuously that causes hydrostatic head pressure. So we want to naturally drain the water. And this is where our geotech engineers can determine what type of drainage is necessary. When I mentioned the path of least resistance, for above grade, really any hole or any discontinuity is a path of least resistance. But for concrete, it's the same, but cracks are going to be one of the biggest issues for moisture intrusion if they're not spanned. Capillary movement, ultimately, water has the ability to rise against gravity because it can enter the structure and one part of the wall, but make its way in other parts of the wall because capillaries are not in a straight line. If you've ever dipped a paper towel into some water, you'll notice that water naturally rises into it. And the reason is because it's made up of so many different fibers that create the small opening, which creates little open ways for water to creep up. You're separating all the water molecules, which means the only thing they can stick to is the side of the opening. And so it can happen in concrete as well. Improper waterproofing details, whether it's by design or shop drawings, ultimately we have to make sure we have the proper transitions, but we also have to make sure they're achievable by the contractor. So we want to make sure that the contractor has accessibility to make the transition, but we also want to ensure that the right products are used because compatibility is one of the biggest concerns when it comes to making any transitions. If you have a grade that slopes towards the structure, that's going to be continuous buildup, and I'd like to defer again to site drainage as being a very important factor to prevent liquid moisture. So what can happen when you do have accumulation? Well, obviously you can have water underneath your feet, like I mentioned earlier, but it can actually damage those interior furnishings as well as the concrete itself. Because with continuous moisture intrusion, one of the most important structural components of concrete is steel, right? Rebar. Well, if you have continuous moisture exposure to it, that passive layer that surrounds it starts to basically dissipate. And then you get the carbonation effect, which causes corrosion of that steel. And a lot of that rust can actually cause spalling of the concrete and reach the face of it. And so now we have a restoration project on our hands. And ultimately, we may be hindering the structural integrity of the building as well. But we also want to prevent any outside toxins from making its way within the wall. And so you don't want to be the gentleman here in the bottom right having to be interrogated because according to AIA, water infiltration is one of the most, or is the leading factor in post-construction litigation. Now, when we select systems, again, not one system is for every situation. If it was, you wouldn't have as many competitors or many product options. And so we do have to differentiate between dampproofing, waterproofing, and vaporproofing. So I'm sorry. Okay. So dampproofing and waterproofing. What's the difference? Because oftentimes we'll see these terms go hand in hand, but truthfully, dampproofing and waterproofing are very different. Dampproofing is one of our earlier methods of moisture control. It's simply just going to be an asphaltic coating that goes on kind of like a paint. However, this is going to be a situation where we're going to use it in maybe less critical areas or where hydrostatic head pressure is not accommodated. So if you have hydrostatic head pressure, this is where we need to upgrade to waterproofing because they're more flexible. Dampproofing is going to be very rigid, and it's also not going to be good for any horizontal applications. So if you have hydrostatic head pressure, it can cause this material to break or dissipate, and it won't span cracks as easily. Waterproofing is going to have added polymers, which gives it its flexibility and durability. So this is going to be a better product for the presence of hydrostatic head pressure. When it comes to The waterproofing types, we have sheet membranes, we have fluid applied, and we have cementitious and blindside. So we're going to break these down individually. For self-adhered sheet membranes, these are probably one of the more common products that we see for your typical below grade applications and even some split slab. And the reason being is because, like some of our self-adhered air barriers, these are controlled thickness. What they're going to consist of is a rubberized asphalt compound laminated to a plastic polyethylene film. Among most manufacturers, these are going to be around 60 mils in thickness, and these are to accommodate those ASTM standards that we discussed for performance. And they will adhere pretty much to anything: wood, concrete, steel if necessary. And what I really like about these products is that the detailing is very simple. The side laps will have a salvaged edge, so we do not have to seal. Any overlap is typically going to use a primer and the appropriate termination sealant. You can use it horizontally and vertically, and with the controlled thickness, ultimately the only thing we are observing is if it's a clean application and if the transitions are accommodated appropriately. For thermal fusible torch-on sheets, these are an option as well. Ultimately, it's going to be a rubberized asphalt sheet that they'll roll out, but to get it to bond, they will use an open flame. So we've seen these types of products for deck applications, and we have seen them used in cold applications just because your typical self-adhered sheet membranes may not be able to accommodate some of these extreme cold temperatures. Now, there are lower and extreme lower temp versions of the self-adhered sheets now available, so do speak with your manufacturer reps regarding the availability of those types of systems. But this is a system that we do see, and while it can be used horizontally and vertically, contractor means and methods for the sake of safety. For fluid applied membranes, we have hot and cold. Now, both have their benefits and both have their drawbacks, and both will be used for certain situations. So let's break them down. For hot apply systems, these are a rubberized asphalt compound. They're typically going to be packaged in blocks of rubberized asphalt that we throw in a metal jacketed kettle. So what I like about these systems is the fact that it's going to be your more robust. They're typically around 215 mils depending on the manufacturer. And with it, you get a lot of square footage covered, and it's very flowable, which means the spread is going to be carried out with pretty good consistency. Depending on the manufacturer, they may require a reinforcing fabric sheet, such as the top right. The purpose of the reinforcing fabric sheet is the fact that we cannot stop the phenomenon of off-gassing from occurring. So what we'll typically do is we'll install a light coat of the hot applied, embed the fabric sheet on top, and then install a more heavier coat on top of the fabric where it's all embedded, but we're also helping ourselves catch some of that off-gassing so we don't get pinholing or bubbling at the top of the membrane. The other thing to think about though with hot applied, we do need to have concrete cured for at least 28 days. And the reason being is because when we're curing our concrete, we don't want to take out one of the most important components of the curing process, which is the water content in the concrete. If we put hot applied on immediately, it's going to potentially cause it to evaporate some of that water content, and we won't get what we need to have a good compressive strength and good structural integrity. For cold applied systems, we have a variety of different options. And so hot applied systems are typically going to be for only split slab deck or roofing or vegetative roofing applications. However, cold apply systems, we can use them for split slab. Some can be used for horizontal. Some can be used for vertical. Some can be used for both. And quite frankly, they're easily packaged, which means that contractors don't have to have any heavy equipment or expensive equipment. So when you look at the top right, this is a split slab application, and we simply pour it from the container and we roll it and spread it out adequately. For the bottom photo, we have someone spraying it. Not all products can be sprayed. Some can only be brushed or troweled, so verify the product with the manufacturer. And some can be STPE moisture cures. So a moisture cure is going to be effective for the sake of a quick cure time and making sure that we can get concrete poured on top whenever it's we're trying to move fairly quickly. The big benefit, though, is also the fact that it can be applied to green concrete. And the benefit of that is just because we do run into situations where concrete schedules are a little bit behind. And like I mentioned earlier, with hot applied, we do need the concrete to be cured for 28 days. But if we are behind schedule, a cold apply system may sometimes be substituted, but these are going to be systems that can be applied to green concrete, and we can move through the schedule fairly quicker. One thing to also consider, accessibility, because when you look at the photo on the top left, our question is, can you get the metal jacketed kettle up to that roof deck if possible? So this is where cold apply systems are oftentimes going to be used if we don't have accessibility for those jacketed kettles. Also, what I really like about the fluid applied is the fact that you do get a really good continuity. You look at the top left photo, all the joints are already pre-treated as well as the drains. And so you start from one side and you work your way to the other. It's really great for planter boxes as well because you have less detailing in some materials that can be used for both horizontal and vertical, typically STBEs. They can be used to pretty much detail the entire box without too much compromise of transitions. On the bottom left, for a vertical wall, pretty smooth, pretty transparent. But again, on the bottom right, for some split slab deck applications or roofing, we will require a reinforcing fabric to give it that added off-gassing protection. It also adds in a little bit of a tensile strength, and so some cold applied systems will require this reinforcing fabric as well, like our hot applied. Now for Blindside, this is going to be a different situation. So in some municipalities or any downtown zero lot line areas, we can't simply pour a wall and then put the waterproofing on the positive side of that wall. So what do? Well, we dig a pit, put up a lagging or a shoring, whether it's wood or even just compacted earth, and then we'll put the waterproofing on first and then pour the concrete to the waterproofing. Where you're typically going to see these types of applications are below grade basements that are very deep, or most commonly below grade parking garages. One of the benefits of Blindside systems is that you can use, for at least depending on some manufacturers, you can use the Blindside membrane for not only the vertical application, but also for the underslab. So you're going to get a really good bathtub protection when you think about some of those really big, large pits. Also to note is that Blindside membranes are going to bond directly to the concrete. So it could be either mechanical bond via fabric or a mechanical bond or chemical bond via an adhesive. Both are great quality bonds. It's a matter of what's preferred, but ultimately both will have their benefits and their negatives. And if you have questions, feel free to reach out to your manufacturers on that. You can install this to shotcrete as well, and shotcrete can be installed directly to the membrane. And so again, a variety of options in terms of how we want to install these materials and what they're capable of achieving. For any waterproofing, we do need protection. Now, for any post-applied application, you're typically going to see protection boards or protective drainage layers. You'll typically see prefabricated drainage layers for Blindside applications, though, as opposed to protection boards. But truth be told, anything can act as a protection board. So even rigid insulation, either XPS or polyiso, those will protect the membranes from backfill as well as UV exposure. Prefabricated drainage layers, though, they have an added benefit because they're dual purpose. Not only are they going to protect the membrane from backfill, but they're also going to protect the membrane from hydrostatic pressure. We can help alleviate that a little bit. We select them based off of a particular flow rate. We also base them off of compressive strength and soil retention. So to simplify this, if you have a vertical wall that's 10 feet, we may not need the most high-end drainage board. If it goes down to 40 feet, 50 feet, we may up the compatibility or the strength of that board. But also think about this, is that if we have a split slab structural deck application, we likely are going to up for the higher end board because we need something that's durable for a topping slab, but also the fabric needs to be strong enough to not punch into the dimples and cause ponding at the very top. And so verify with your manufacturers or even the geotech engineers that can help us to dictate which type of board we need. To finish on the waterproofing side, we have cementitious. So we have both crystalline and flexible. Now with crystalline waterproofing, this can come in a variety of different types, and flexible typically is going to come in a different variety of different types as well. However, crystalline is usually the simplest to differentiate. With crystalline waterproofing, crystalline can either be an additive, which is an integral admix to the concrete batch. I actually really like this type of method simply because you get a reaction with majority of the concrete slab. But ultimately, what it's going to do is react with any leftover in calcium hydroxide, basically the free lime. It's a byproduct of concrete. It's going to create calcium silicate hydroxide. So basically, we're plugging the pores of the concrete and we're making it more water resistive. We do also have post-applied spray crystalline materials that are available in our industry, which is shown here on the right. And so the difference between this and the additive is that this will leave a coating, and you can use it both on the inside or the outside of our walls because they're breathable. Also, it is going to get some penetration within to get some reaction. So it does become integral with the concrete in a way, but it also does leave a coating. So I really like seeing these materials on the inside of water tanks or on the outside if it is going to be exposed indefinitely. I also like to see it on the inside of elevator pits just because I believe it's going to add some extra protection. And with it being breathable, we're not having two vapor barriers within the wall. Flexible cementitious membranes, these are going to be your upsell, but they're also going to be very durable in the sense of if you have water tanks, both wastewater, potable water, or large fountains, it's good to have a flexible membrane because it's going to be able to accommodate concrete movement a little bit better than crystalline. Also, when it comes to repair or detailing, it's fairly simple and likely won't have to require a variety of different accessories to achieve the continuity. When it comes to water, wastewater, we do have chemical resistant formulations available in this industry. And so if we do have to use it for potable water, make sure that it does have that NSF 61 approval. But again, like our crystalline, it is UV stable and we can have it exposed indefinitely. And so I have seen these types of products used for foundation footings as well as any above grade concrete walls. So where you can also see this, I already mentioned the top four, but we do see these in parking garages as well. Particularly when it comes to crystalline, you can actually use this as an additive mix with the concrete walls for parking garages, even in a blindside application. It works great in conjunction with blindside waterproofing membranes. And so ultimately you have a really good belts and suspenders approach in that regard. We do see them in basements, but we also see them in restoration projects if we have an active leak. So if there is an active leak, we'll simply use a hydraulic cement repair mortar to repair the leak, and then we'll typically install the coating on the inside of that wall. Swimming pools, not so much, we don't see them as much for residential pools to be transparent, but we do see them for natatoriums and we do see them for recreational pools. To give some photos, on the top left is a good surface profile. We typically want a CSP 3 or 4 when we install these materials. And as you can see in the there, you also have a slurry coating to show how it's going to adhere to it. The top right is a gentleman who's going to wet the wall. This is going to make sure that the membrane gets adequate bite as well as good penetration if you are using a crystalline because water is part of the activation process. Bottom left in a water reservoir or collection tank, this is going to be the gentleman spraying on the wall, but on the two bottom photos, they also are going to spray the bottom of the tank because you can use it for horizontal application. So you will get a good bathtub effect here. And the bottom right photo shows the walls coated first. Before they can actually spray the horizontal application, they will have to remove all the equipment and all the added accessories that are still in there. To finish off, we have vapor control. Now, when it comes to vapor control, we obviously are going to think about our underslab because soil contents are always going to be around 55 degrees in temperature, but 100% relative humidity. So you have a high vapor pressure content, and it's going to permeate through the concrete because concrete is not a good vapor barrier. The area of high pressure is going to want to move to the area of low pressure, which is through the pores of that concrete and into our conditioned space. Just to not throw too many numbers, but to give you some idea of how this occurs, well, when you take the soil contents of 55 degrees and 100% relative humidity, you get a vapor pressure about 0.214 psi. But if we take our interior condition space of 70 degrees and 30% relative humidity, you're going to get a pressure of about 0.108 psi. So what does that exactly mean? Well, we're going to get a difference in pressure, or a delta P, of 0.106 psi. And anytime you have a difference in pressure, it's going to try to transfer to reach a state of equilibrium. So in other words, you're going to get 10 gallons of water for every 1,000 square feet per day, every day within the building, because naturally we're going to get that moisture carried through the concrete, and we get things like sweating on the slab or just puddles of water as well. So some of the things that you may notice with this is that if you have any flooring, whether it's an epoxy flooring or carpet or any tiles and adhesives, it is going to cause it to potentially debond. And so this is where ACI is an important standard to reference when it comes to some of those sensitive flooring systems. But also if you have any things like paints or any type of other decorative coatings, it can cause warping and it can cause a discoloration. And one of the other things that it can cause is natural deterioration of the concrete. When you look at the top right photo, you can get rebar exposed just because that carbonation effect will cause spalling and make its way to the face of the concrete. If you have any wooden gym floors, you can get warping and buckling. And an example of warping is actually on the bottom right with some other types of tile finishes. Typical products that we will see being utilized for the protection are plastic vapor barriers and vapor retarders. Now, the material defining standard is ASTM E1745 for these plastics, and these two photos are demonstrating these plastics being installed. Probably the more common product that we see, simply because it's a lot of square footage with fairly easy detailing and a little bit less babysitting, because ultimately it's easy to roll out, and the taping the overlaps is all we have to do, as well as around the penetrations. They have an extreme low water vapor permeance, and they do have a pretty good puncture resistance as well. Now, a lot of that technical data will be on the data sheet, and there are industry standards related to what type of membrane we need to use for the sake of its strength. And so typically we're going to have a class 1, class A vapor retarder. Class 1 simply means that only 0.1 perms or less can pass through, and it will have the highest puncture resistance. Class B, or A, B, and C are going to represent the puncture resistance. And so this is why we typically will see a class 1, class A retarder used. We also have to take into account that if there are radon and methane emissions, a lot of these typical plastics will resist it. But if we have high concentrations or any BTEX contaminants, we may need to upgrade to an actual gas barrier. And so it's not a matter of the mill thickness, it's going to be a matter of what ingredients are going to help protect it against gas. So that's going to include things like EBOH, which is ethyl vinyl alcohol. Now, at one time, vapor barrier and vapor retarder were considered the same thing, and we tend to confuse the industry in terms of which name do we actually use. Well, ASTM is actually going to recognize retarder as the more appropriate term. And the reason being is because when it comes to these plastics, they are going to allow a little bit of permeability. So E1745, for it to be a class 1, it's going to be 0.1 perms or less, but for it to classify as a true vapor barrier, it'll only have a rating of 0.01 perms or less that are going to pass through. So a lot of your waterproofing membranes, both vertical and underslab, they will classify as barriers simply because they're going to allow typically even less than 0.01 perms to pass through. Verify it with your manufacturer reps as far as which products they recommend if we do have to meet these particular standards. Some of these industry standards, we already went over the plastics, which are going to fall under E1745. However, if it does have any asphaltic properties, it's likely going to fall under ASTM E1993. And so for some of the underslab waterproofing membranes that have asphaltic properties, this is the standard that it will fall under. E1643 is just a standard practice for how we select products, how we design them, and how we install them and inspect them as well. So This is something that we will list, and it is helpful for quality assurance and quality control. ACI, not really a standard, but more to serve as a guide. And so they use this for concrete practices as well as curing as sealing. However, we can use it to help us select materials that are needed under slab, especially if we do have sensitive flooring on top, such as those tiles, densification, or any epoxy floorings. Where do we place the membrane? Now, we defer to the engineer to make this choice. However, there's arguments about having a blotter layer between the membrane as opposed to having the membrane directly underneath the concrete slab. I personally am more partial to having the membrane underneath the slab just because I want us to make sure that we inspect the slab, that there's no damage. Because if we do have a blotter layer, there is potential that we will miss some of the area that is damaged because a hole is going to be much more critical compared to just the permeability of a membrane. So the reason why the blotter layer is introduced is because engineers do fear about slab curling, which means the slab is literally going to curl from the left and the right. However, it is possible for slab curling to occur even in this regard, just because if moisture is bleeding down into the blotter layer, it may have the potential to create a lot of pressure underneath and could cause slab curling over time. However, again, we do like to defer to the engineer in this regard, and we will support their decision. So here's some photos of the application. On the top left, you'll see that these are fairly large rolls, and because you can cover a lot of square footage, you are going to need some sandbags to hold this thing down because it's not as heavy as you want to think it would be. And ultimately, if we get enough wind pickup, it will move that membrane around. And so, unfortunately, the manufacturers of the retarders will not provide the sandbags. In the middle photo, you'll see that it's a pretty simple detail. You're just going to use a vapor impermeable tape, and most manufacturers should provide this as an accessory to complete the system. And on the right, you'll see that we have a lot of penetrations as well. So any protrusions or penetrations, they will be detailed with the tape. However, not all penetrations are in a straight line like that cluster you see in the middle of that bottom right photo. So if we do have clusters of penetrations that are less of an inch spacing in between, we may have to opt to build a dam and fill it with an epoxy or a liquid membrane to help fill and seal around all penetrations. To finish off, things that can actually influence the product effectiveness: design, obviously. Design is going to be simply, are we making the appropriate transitions and are we actually encapsulating our building appropriately? Think of the pencil test. Also, do we select the right materials that can be durable enough to handle not only the transportation, the UV exposure, but how long is it going to last on the building? Also, what about the workmanship? You can have the perfect design, the perfect materials, but we're only as good as the installation from our subcontractor partners. And so most manufacturers should be able to provide training, and some may even have approved applicator programs regarding the quality of workmanship that can be potentially achieved. And for quality assurance, this can be achieved obviously during your design development, during the construction documents, but we also want to see this in the pre-construction meetings. When you think about the design and specifications, we have to make sure these products are going to meet any industry standards as well as local codes if there are particular code requirements. And so if it's a proprietary spec, we may have a basis of design. And so with the basis of design, just ensure that if we do list a few manufacturers that are approved, that they do have products that are available and that are as close to that basis of design product as possible. If it is performance-based, make sure the products are as similar in the performance characteristics, because oftentimes we may see different products that will be functional equivalents, but maybe it's a thin mill and then you have a medium build. In that situation, your subcontractors will just submit the lowest cost option. And also, we understand that compatibility is a major concern, and so we want them to be compatible with any peripheral systems or if you have any adjacent materials. So if you have a PVC pipe coming through the wall, make sure that material that's waterproofing can seal around it and not have any compatibility concerns. But we also understand the fact that not every time are we going to have the same manufacturer single sourcing all the envelope material, but they are going to make a connection, right? Just ensure that if one manufacturer connects to another, that they are compatible. And a rule of thumb that I always have is that whichever manufacturer's product is going on top of the product that's already installed, the one coming on top has to write the letter of compatibility should they have any concerns. And so it is a benefit if a manufacturer does single source the underslab, the below grade, the above grade, and the roofing. And so just verify with your manufacturer reps on what their availabilities are, because they may be able to offer options that help make the warranty process a lot easier. But pre-construction meetings, these are going to be amongst the most important ways for us to help have quality control, but also not to have any issues during the construction. So when you think about pre-construction meetings, I want to see manufacturer reps, the subcontractors, and all trades that are going to come into contact with these moisture protection systems. Because the things that have to come into consideration, the application, the compatibility of the accessories and adjacent materials, and the scheduling. When can the brick facade installer put the brick up? Well, we have to make sure detailing of the air barriers is done. When can the backfill go in, and how do they backfill to not damage the waterproofing? Also, if we have a mock-up, we want to look and see what's touching, not just how pretty the building is going to look. Because when we see what's touching, and if there's an issue in terms of compatibility or a missing transition, we can fix it there as opposed to having to fix it on the actual building going up. So in summary, moisture movement, it's going to happen. And no matter what, we have to control it. And because we can't control physics, but we can help mitigate it from entering our buildings if possible. So we want to select materials and systems based on project requirements, the climate it's in, but also with performance requirements. We want to consider the key design and installation of these materials, but understand that some products may be better for certain installations than others, and may even save time and money for those practices. So